In this unit, we're going to be talking circles and circular measure. This is going to be the lead up into us talking about trigonometry. Why we look at circles? We look at circles because they help us quantify angles, and it goes beyond just math. Airport runways are labeled in degree measurements. Your tires are aligned using angular measure, and some of the things we use every day, like our cell phones, our laptops, or our televisions, all have a metric of viewing angle put on them. So what you're going to be able to do at the end of this unit is understand the definition of a radian and understand the relationship between degrees and radians, and then you'd be able to use the formulas of arc length and sector area in solving problems. So starting out with, let's talk about a degree and what a degree is. So degree in terms of a unit of measure, a circle is divided up into 360 degrees. And if you ever wondered why, it's because the Babylonians were one of the first ones to investigate circular measure, and they had a base 60 system. They realized that there was a ratio of the perimeter of a hexagon to the circumference of the circumscribed circle equaling 24/5. And because they had a base 60 system, 360 is divisible by lots of factors. 360 has, in fact, 24 factors. And because of that, that's where 360 degrees all came out of. It was in 360 for a long time was used as the number of days in a year, because it had so many factors and was nicely divided. And then the little circle, so if we 25 degrees, the little circle came from the Egyptians. Actually, they gave us that symbol. So we have degrees, so the distance around a circle. And then let's talk about a radian. Okay, radian is an arc equal in length to the radius of a circle. So let me get, this will work. So if you take the radius of a circle, r, okay, and wrap that radius around the perimeter of a circle, and then connect it back to the center, this angle in here, that's 1 radian. So a radian is 1 radius of arc length around a circle. So to convert from degrees to radians, you multiply by pi over 180. If you think of it as a ratio, so if we have, if I am in degrees and I want to go to radians, my ratio needs to be radians over degrees. So it's going to be 2 pi over 360. And then that fraction reduces to pi over 180. So that's where this ratio comes from. To go the other way, so to convert from radians to degrees, your ratio is just flipped. So arc length. So if we think of a circle, we're talking about arc length. It's the distance around the perimeter of a circle. And the way that works is r theta. So where that comes from is the circumference of a circle is 2 pi r. And we want some proportion of the circle. So we want some theta out of 2 pi, out of the whole circle, right? This is the fraction of the circle. 2 pi cancel out. We're left with our formula of r theta. This only works for radians. Theta has to be in rad. Right? You'd have to write a different formula for degrees if you wanted to do it that way, and it gets complicated. Now we have area of a sector. So a sector is simply part of a circle. Think it's a slice of pizza. And this formula tells us how we can find the area of that pizza slice, which is r squared theta over 2. So again, if we think of pi r squared is the area of a circle, and if we want a sector of a circle, so we want the sector area, we're going to have the whole circle times some fraction of the circle. So that's where our formula comes from for area of a sector. Both area of a sector and arc length are on your formula sheet, so you don't need to memorize them, but you do need to know how to use them. So let's look at a couple practice problems. So we need to find pi. We'll find in terms of pi the length of the sector. Oh, we've got a couple different things going on here. Okay, so let's look at A. So we need arc length, which is r theta. So if r is 8 pi over 4, okay, r times our angle simplifies to 2 pi. And then B, radius of 16 and an angle of 3 pi over 8. So 3 pi over 8. 8 times 2 is 16, so that's equal to 6 pi. So that's those two. And then let's take a look at this one. Calculate the length of QR. So this is going to be a tan theta equaling opposite over adjacent. So tan of 1 radian is equal to O over 5. So 5 tan 1 equals O. And you just make sure your calculator is in radian mode. And then we can do, we get that it is 7.787 centimeters. So for a circular measure, you need to know what a degree and a radian is. You need to know how to convert between them. You need to understand what a sector is and how to use the area formula to find the area of a sector. And then you need to understand what an arc or an arc length is and the formula for arc length. That is the end of circular measure. It's a very short chapter, but there's a lot of practice that we need to do. So your homework is 113, 5, 7, 9, and 10.